So now we're going to pick up on page 137. We're going to look at completing the square again and taking the square roots. So today's lesson will be about two things: taking square roots and completing the square. And all of these, we're going to be solving quadratic equations. So if you struggled yesterday with the factoring, this is another method. So let's start with solving. So solving is really just solving for x. So notice right here, we need to get x by itself. So we move the 23 over by adding. So now we have 5x squared equals 23. We divide by 5. So now we have x squared equals 23 over 5. Now we want to undo that square root. Well, the opposite of raising something to the power of 2, or the inverse of that power of 2, is square root. So notice what we do. We take the square root of the top and the bottom, the whole thing, we take the square root of. So that means whenever we take square roots, we get two answers, a positive and a negative, that plus or minus. So let's try one. So first, let's move over that constant, that negative 49. So to do that, we will add 49 to both sides. So now we have 9x squared equals 49. Again, we're trying to get x by itself. This whole thing is about solving for x. So we'll divide both sides by that number in front, so the coefficient of 9. So we have x squared equals 49 over 9. Now our whole goal is to get x by itself. Right now we have x squared. We're super close. So we can take the square root. The inverse of raising something to the power of 2 is square root. Now notice when we take the square root, we're taking the square root of this entire fraction, both the numerator and the denominator. So let's see what happens. So square root of x squared is x. When we take square roots, go ahead and put that plus minus because there's always two answers. So right here in the numerator, we have square root of 49. Well, square root of 49, that's a perfect square. That's 7. Notice in our denominator, we have square root of 9. Well, square root of 9 is a perfect square. We get 3. So that is our answer, plus or minus 7 over 3. Let's look at another example. So 25x squared minus 7 equals 0. It's going to be the same process. Move the constant, divide by the number in front, take the square root. You're going to be doing that every time with solving. So we now have 25x squared equals 7, because I added the 7. Now I'm going to divide by 25. So now we have x squared equals 7 divided by 25. To cancel out, or the inverse of that power of 2, that's the square root. So we have x equals plus or minus. So we're taking the square root of 7. Notice the square root of 7 is not a perfect square. So all we can do is just write square root 7. Notice that denominator, square root of 25, is a perfect square. So we write 5. So that's our answer. A positive and a negative, square root of 7 over 5. All of these have two answers. So let's look at a couple more. Let's look at 5x squared minus 16. First thing, move over that constant, add the 16. So we have 5x squared equals positive 16. Notice we need to undo or do the inverse of this multiplication, so we divide by 5. So we now have x squared equals 16 over 5. So all we have to do now is do the inverse of the power of 2, or squaring something. So that would be square root. So notice we're taking the square root of both the top and the bottom. So another way I could write this would be like square root of 16 divided by square root of 5. If you want to separate those square roots, that's fine. So now we have x equals, well, square root of 16, that's 4. Square root of 5 is not a perfect square, so we're going to leave that as square root of 5. Don't forget, we should have a plus and a minus out in front, because this represents two values, a 4 over square root 5 and a negative 4 divided by square root of 5. Those are your two answers. Okay, last one here. Same process. We will subtract this 15. We're going to do the inverse of a positive 15. So we now have 4x squared equals negative 15. Now we will divide by 4. So we have x squared equals negative 15 divided by 4. We then do its inverse. The inverse of a power of 2 is a square root. So we take the square root of everything, this entire fraction. So that means this negative 15 and this 4, both of them we're taking the square root of. So now we have x equals, notice we have square root of a negative number. Anytime you have square root of a negative number, you know there's going to be an imaginary term. So over here to the side, remember, square root of negative 1 means there's an I. So if you have square root of negative 15, that's really square root of negative 1 times square root of 15. So that's I square root of 15. So that's what our numerator is, I square root of 15. Okay, look at our denominator, square root of 4. It's a perfect square. It's 2. We put plus, minus. So this is an example where you get an imaginary answer at the end.